My name is Amos Sinyanya and I will be presenting my project. So welcome all. This is the title of my project, Intelligent Shopping System. And this is the aim of my project, to introduce a self-service shopping, save costs on human resources, and generate more revenue. This is the methodology that I've used, law of conservation of energy. This can be considered when the electrical energy is converted to mechanical to run the motor, and also the conveyor for the customer to run their belongings that they're gonna pay at the till. So this is the methodology. This is the human resource HR. This is average shopping time, and these are salaries. So as you can see on the graph, so this represents the salaries. So on year one, on the start of the introduction of this system, so the salaries will be that much because the head count in terms of human resources will be sitting on 18. So on year two, the cut down would have started then, because the system would be self-sustaining itself. So there wouldn't be much of HR personnel, human resource personnel. So on year two, as you can be seen, that the salaries are dropping. This is the amount of salaries that are paid, and then it gets down to that number. And then as we can see, the behavior of revenue from year one up until year five, we can see that it's going up. And these are the minutes that the customers will be using to shop. So as we can see on year five, they will be sitting in 10 minutes for the shopping that they were doing in an hour, which is 60 minutes. This is my flowchart diagram where I'm showing that when the distance is less than 10 centimeter, then the servo motor runs to open the door, and then the customer gets inside. And then when the customer is inside, they run their they do their shopping, and then they use a push button to pay, and then the motor will run for every item that's been put on top of the conveyor. And then when they go to the exit door, the DHT sensor is used as a theft scan sensor, and when it's less than 40, it will then signal the customer to scale their belongings on the exit scaler. And then if the weight on the exit scaler agrees with the weight on the till scaler, that is when then the communication will be sent will be displayed to the customer to press the push button to open the exit door. So this is my block diagram. So a push button is used to show the scan of the items and also to pay. So this is the weight scaler on the till, and then this weight scaler should communicate with the weight scaler at the exit door. And then this is a theft scanner that is used as a humidity sensor. This is a push button to open the door when exiting the door. These are the LEDs that are used with a relay. One is used for opening the door, and one is used for closing the door. This is my schematic diagram for the project. I'm gonna explain it more or in detail on the second part of this video, because it's not very clear on this picture. And this is the picture of my project. And as you can see, this is just at the beginning after the simulation. So as you can see, it shows the enjoy shopping. Thank you. Moving to the second part of my project. So this is my project. So that is the screen, and it's showing that enjoy your shopping. And this is the serial monitor / console where I'm displaying the values as they are on my project. And this is ThinkSpeak, the website that displays an output now. So it's working on a real time. So I'm about to refresh it again. As you can see, it's less than a minute since it's refreshed. And now I'm refreshing it again. Here I'm showing the distance when the motor is moving, that is servo motor, and also DC motor, humidity and temperature from DHT11, and also the weight of the scaler from the till, and also the exit. So going back to the project, as I said, this is a serial monitor that displays the values that I can see also on ThinkSpeak website, the website that's displaying the output on a real time. So the project, when there's a customer in front of the door, I'm about to put my hand in front of the ultrasonic sensor. So here is my hand, I'm putting it in front of the ultrasonic sensor. The motor is running to open the door, and once I remove it, the motor goes back, that is to close the door. And the display on the LCD is the custom welcome to shopping. So after that, the customers will then proceed to do their shopping, and after they're done with their shopping, they will then use the push button to signal the paying. So that is the customer paying, and when all items are paid, then the display on the LCD will signal the customer to weigh their belongings to the till scaler. So that is the till scaler made out of load cell, and that is the interface in front of the load cell. So after that, then the communication will signal the customer to go to the theft scanner theft item scanner, which is a DHT11, and when it's less than 40, then it means there's nothing stolen, and then the display on the LCD shows the customer to proceed to exit scaler. The value on the exit scaler should agree with the value on the till scaler. The push button then is for the customer to open the exit door. As you can see, it shows that the door is open, and the red LED shows that the door is open. For when there are stolen items, and then the alarm will come on. So on the DHT sensor, the value is above 40, that is humidity, and when it's above 40, it shows that there are stolen items. The system will then sound the alarm inside the shop and also to the control room for the security personnel or the control room personnel to attend to the situation, so that if there are anything stolen, they can be attended to. If it's a malfunction on the system, then the control room operator can come and reset the system so that it goes back to normal. And the system will sound an alarm, stops up until there's an attention. If there's no attention from control room personnel, it will again sound the alarm. So this is ThinkSpeak, where I'm showing the values as they are on the till scaler that I've just measured. So again, they show on the website. I've started. So the reporting is on my code, and then from my code is the PC schematic diagram, and then from schematic diagram is the PCB, and then from the PCB everything is color rating that I've displayed on the ThinkSpeak website. So with that being said, I want to say thank you for you to listen and watch. So that is all on my side. Salute.